Welcome to today's sections about using Google Colab to run the Python libraries for machine learning. So last week, we have shown how to use an app to train the machine to identify and recognize different people by their photos without any coding. Indeed, if you are interested in knowing about how the computer can carry out image recognition process, here is an example showing you step by step. And you can log in to Google Colab, and there's example lab 5 using convolutions with complex images. And I will show the link below. And this Colab provides us to write blocks of Python codes by using this plus code button, or you can write explanation text in between by clicking this plus text button. Of course, this one would be quite complicated to you if you are using Python codes the first time. Maybe we can try using a simpler introduction one. So here you will see that you can click File and you can build a new notebook or open an existing notebook to build your own libraries. And all the notebooks will be run on the Google Cloud. So let's build a new notebook to demonstrate how to use Python codes to run a linear simple regression, which can be understood as a simple linear polynomial function y equal to ax plus b, or machine learning language. It is equivalent to a single layer artificial neural network. So once you open a new notebook, you will find that there is this kind of block with this circle arrow, just like the play button. These are provided for writing Python code. And after that, you can press this play button to run the code. So let me show you how to run a linear regression step by step. So the first step is always an import statement to import the required tools, such as TensorFlow and Keras. Let me show you how to do that. That is, import, then type TensorFlow, and we define a short form, TF, to stand for TensorFlow. The second step is to import NumPy, S, and P. And then from TensorFlow, import Keras. So we do not have to understand what they are. These are the first block of Python code to prepare the environment for running. So after that, you can click the play button, then it will show hidden circle. When you finish, then the hidden circle will be gone. Then you can write text by clicking this text button, or you can write another block of Python code. The second step is to define the model. So we type model equal to tf dot Keras, and now we are using the simplest sequential linear regression. And now we are trying to use the single layer, just like this example, right? You can choose sequential single layer. So we open bracket and Keras dot layers, dense, open bracket, unit equal 1, comma, input shape equal 1. Okay. Next line, right after defining the model, now you can run this library. Yeah. And then next block is to define the optimizer and loss function. So we compile the model with the optimizer SGD, and the loss function mean square error. Okay, so after defining the model, single layer, sequential, and define the model, optimizer, and loss function, then we can provide the data. And here in this example, we simply type in the 3 sets of data. Say, for example, when x is 0, 1, 2, 3, and the data type float type, close bracket. Then we type in the corresponding y rate. So when x is 1, how about we try to build y equal to 10x plus 10. So when x is 1, y would be 20. When x is 2, y is 30. When x is 3, y is 40. When x is 4, y is 50, etc. Then I intentionally make a mistake, and you will find that when you run, it will tell you the mistake, right? The X array is a syntax error, and if you check, then you will find that we put an extra bracket here. So delete it, rerun, another syntax error in Y array, and you will find that indeed we miss a bracket here. So now rerun, and you will find that it works. Okay, almost the end now. So now we can train the model by using this model.fit function, and we ask the machines to try guessing the XY relationship by the 4 sample to try 100 times. So let's see how good the machine can learn. And you will find every step, right? The machine try to reduce the loss function. That means it is getting closer and closer until it achieves 100 times of training. Okay, let's see after this 100 times training, how good in understanding about our model. So we cook the last line to print, that means to report the model.predict function and open bracket. And now we give a value 100 as the X and ask the machine to predict the Y. So our expectation is when X is 100, Y should be 1010. Let's see how good. Oh, it gets the result as 1338. Not bad, but is still far from the truth. Then if you can provide more experience and training to the machine, the accuracy can be improved. So this is so simple that there are only 6 steps. Then we can run the first machine learning Python code to train the machine to understand a simple linear. That's all for today. Thank you.